Good morning, everyone. My name is William Andrzejewski. I'm the Senior Technical Support Specialist for W2 Garment Systems. And today we're going to be talking about an introduction to troubleshooting W2 network systems. First thing we like to talk about is what is a network? A network is defined as a connection between at least two computer systems, either by cable or by a wireless connection. Some way they're able to talk. And what are they talking about? It's going to be an exchange of informations, resources, and services. First type of network we're going to talk about is CAN bus. CAN bus is our controlled area network. And basically what this is doing is connecting a bunch of different machines together. And all these machines are equal as far as their status. It's not like one of them is acting as a server or something like that. These are all independent and they're all working together. It's going to use knots or nodes for addressing, uses a two-wire bus to connect to each other. And those wires are going to consist of a CAN high and a CAN low, in addition with the ground. We're going to also require shielding to prevent interference, and we're going to have the incorporation of a 120 ohm resistor, and this is going to be required at the terminal connection of this. Now, it's going to be connected between the CAN high and the CAN low. And when you're measuring this, you're going to be looking for 60 ohms. So here we have an example of a CAN bus network. Over here we can see our main call-off panel. So this is serving as the main machine of the transline system. And then these purple lines are going to be representing different CAN buses. You can see we got one CAN bus that's going from the transline, and it'll be connecting and interfacing with the XMT tunnel finisher, and then it can carry over and go to multiple folding machines. And in addition, we can see we have a separate CAN bus network coming from the transline call-off panel. And over here, what it's doing is it's connecting to each of the different inverters, and each one of these inverters is being used to control the different conveyors as far as their speed and their connections with the motors that they're driving. So we can have multiple CAN bus networks, and we can see that in this diagram. This is our CAN bus topology, and these are taken directly from the electrical manual. And over here we can see we can have a CAN bus connection for our machines, which is basically showing us this is coming from the transline. This first connection is where it's originating at. Its node address is going to be a 1. These node addresses serve just like IP addresses, and it's letting the network know which station is where, so that the commands and controls can be sent to the different ones. So from the trans line, we can see that it goes to number 5 node address, which is FAX2, and then it'll go to FAX number 1, which is 6 and 4. Over here, we can see a CAN bus addressing for all of our FUs, our frequency inverters. Over here, we can see that this is the last inverter in line. Therefore, it's displaying that there needs to be a terminal resistor, that 120 ohm resistor inserted in here. Same thing on this one. This is the end of the line. We can see these two lines are joined, and they're both originating from the same spot. And this is the end of the line. Down here, we can see another CAN bus line that's for all our MBTs. These are our little data entry points for the marriaging of the garments and the hangers. Over here, we can see where the CAN bus network actually plugs into. So if we look at position number 9 over here, this is the empty slot on where the module for the CAN bus would go. And this is the plug-in point for different interface modules. Here is the module. So this is going to be our IF 2772 module. Here we can see where the buttons are for putting in the node address for the originating station. We also got some different LED statuses that we can see whether it's active or if it's booting up. We can see whether we're transmitting and receiving over the different CAN lines. So over here, you can see we got a CAN 1 and a CAN 2. So we can have multiple CAN lines coming out, controlling those different things like we saw in the previous slide with the machines or the frequency inverters or the MBTs. And then we have some LED lights down here showing you whether or not we have the resistor, the termination resistor turned on or not, depending on whether it's at the end of the line. And then on the underside of the module itself, you can see over here we have the 2 dip switches to incorporate or segregate the resistor. Here's a picture of the same PLC with the interface module inserted. This is coming from the electronics diagram. So over here, once again, this is in the slot 1. This is the interface module. Over here, we can see the terminal address for this module. So this one is set for position 1. Over here, we can see the 2 CAN lines that are in this module. So down here is IF1 for CAN line 1, IF2 for CAN line 2. And then over here, we show whether or not the resistors are incorporated or segregated depending on where they come at. Also down here, usually they'll give you a blow up. So over here we see IF CAN 1. Over here we see IF CAN 2. And it'll show us that all the different areas that these different CAN lines are going to. So these are going to all these different components. And then over here for IF2, this is what's incorporated into all of these. So this can help you in your isolation and troubleshooting. If you're seeing you're having a communication issue, perceived communication issue, you can identify the components, the areas that are affected, and then you can bounce them off here and see if it has a commonality with a certain CAN line. So next we're going to talk about some CAN bus troubleshooting and some systems. So uh, one symptom we could see is the machine is reporting to be offline, but the machine is powered up. Some messages that we could be seeing is conveyor technology off. So this would be an example of like on the XMT. The XMT may be showing you conveyor technology off. You look at the conveyor technology, which is the trans line, and obviously your trans line is turned on. You may even have conveyors moving. Another message you might see is outlet occupied. Outlet occupied would be like on your FAX. Your FAX is bringing the hanger and the garment in. It's removing the hanger. It's being drawn out. And now it's all just there at the exit waiting to throw it off onto the trans line, but it can't because it says outlet occupied or something like that. That's letting you know that those machines are not talking. Machine A is saying machine B is off. Another indication you may have is flashing red LEDs on your inverter. So over here in the picture, we can see that we have normally a solid green light on our inverters when everything is up and running and correct. And if this is a flashing red light, then we would be an indication that the inverter is not communicating with the CAN bus line. Additionally, on our X67 modules, we see we have position A and position B over here. We have two LED lights, and if those are red, that can be an indication also that we have been removed or not communicating correctly with the CAN bus line. So for fault isolation of a CAN bus, you want to check the machines are all powered on and fully booted, and you want to make sure there's no messages. Okay, those messages such as the outlet occupied or stuff like that, that can be a good troubleshooting clue for you. You want to check that CAN information screen is actually showing some activity. We want to check cable connections and measure resistance with power off. If all that checks out good, we could just do a full power down and reboot. Sometimes if there was a interruption, these networks may not automatically reestablish while the system is on. So sometimes just powering off, powering it back on allows everything to go through its setup cycle and therefore reestablish the normal communications. Reterminate or replace cables or replace IF modules. So over here, this is our CAN communication. Okay, so this is on your transline CTT, and you are actually able to go into your service mode and you can bring up the different machines that the transline is trying to communicate with. And what you would see is the example here. This is CAN communication with finisher 1. And what I'm doing right now is I'm seeing the different command signals and everything between the XMT and the transline. Now, all I'm looking for here really is, do I have lights and are lights coming on and off? Okay, I'm looking for general communications between these two systems. As long as this is not all red, then I know that I have the CAN internal network is satisfied and it is communicating back and forth. So don't worry about necessarily what these different variables are. Just look and see if you have status lights on here that are green and probably going on and off. All right. With checking connections, there's several different kinds of connections. Here we could have just a plug type connection like we have right here. Once again, here's a dip switch on the plug connection for resistor on or off. In some of our setups, they're actually going to be just hardwired in. So here we see our purple cable coming in, and then we have our CAN high, our CAN low, and our shield or our ground over here. When measuring these, if you get your meter on, you can see the black lead and the red lead down here. With the machine off, if you go across those, we should be seeing 60 ohms. And 60 ohms is what we need to see. As we start getting into the points, 60.1, 2, 3, those are showing us some possible issues. If we could have 61 or 62 ohms, that's no good. So we want to be as close to 60 as possible between CAN high and CAN low. When measuring CAN high to shield or CAN low to shield, we should have a open All right, next type of network we're going to be talking about is our Ethernet LAN. Okay, uh, this connects several components together with assigned rights. So this is going to be attached to a server. Um, they can have static or dynamic IP addressing. You're going to use RJ45 cable connections, and they can be 4 or 8 pin connections depending on the speed of the network. So down here we see our RJ45, and then over here we can see our Cat6 cable lean, and then here's the individual twisted pairs that help make up those 4 or 8 connections. When we're dealing with an Ethernet LAN network, all these items are going to be connected together via the network. Here we can see all our individual devices. They're all going to be going back to some kind of switch, and then from here they go back and will be connected into the server. So this is giving anything that has data or has needs connectivity with the server to establish some kind of protocol, to establish some kind of um, data exchange of the garments coming in, the garments going out of the system, batch exchanges, and sorting procedure steps is the other big thing. That's what's dealing with the Ethernet LAN network. So on this previous slide, we had a very simple one of a network. Here we can see a more complex one. Here we can see all the machines that are all assigned to that Ethernet network. With our Ethernet LAN network, we're going to have designated IP ranges for the different devices that are out there. So if we look out here, all W1 stuff, that's going to be all your finishing items, your feeders, folders, ironers, those kinds of things are all going to have IP addresses from the 10.8.1.1 through the .255. W2 will be on the 10.8.2 network. W3 can be on the 10.8.3 network, and so on for our different devices. So it's very important to understand the IP scheme you're on. Static IP addresses. So we mentioned earlier that these things may be dynamic or static. Um, Static IP addresses, those are manually configured, so they're never going to change. So when I say this machine is 10.8.2.2, no matter if we turn it on, turn it off, remove it from the network, put it back into the network um, electronically or something like that, it's always going to have that same 10.8.2.2. These are going to be used for servers, remote access, and devices that are requiring constant connectivity. They're more reliable for web hosting, VPNs, and network printers. Downside, they do have to have a manual setup, and because they're once and forever always, you want to make sure that you have your proper security stuff installed um, so that we are managing these and we're not allowing any vulnerabilities to be put into the system. Dynamic, just as it sounds, these are signed automatically by the DHCP, the Dynamic Host Configuration Protocol Server. These are going to change periodically, usually after the device disconnects and reconnects back to the network. These are commonly used by ISPs, internet service providers, for home users. They're more secure because they're always changing, so nobody will have your IP forever and always. The problem with that is if IPs are changing, that makes troubleshooting more difficult. So customer calls and says, hey, I need you to go look at my um, computer monitor that this situation's going on, and they have changed it to dynamic, and now I'm expecting to have a 10.8.2.111 to go look at this monitor, and now it's changed. That's going to make troubleshooting very difficult. So that's why we're managing these, and for most of the W2 stuff, everything is going to be a static IP. Color coding. So we saw those twisted pairs earlier, and we said that they could be either a 4 or an 8 wire connection depending on the speed. For the W2, we're always going to have an 8 pin connection, and then we can see our color coding with the orange and white wire going to 1, orange going to 2, white and green going to 3, and so on with all the color coding. So this will enable you, if you do have to replace a connector because it got damaged or become loose or something like that, you'll be able to use this to reconnect it. Symptoms that you could see if you were troubleshooting internet networks, Ethernet networks. Your HMI, your human machine interface, is displaying a message. So on the CTT, you may see something like log tracking data is full. That's telling you that the PLC has stored as much information as it can. It's trying to push that information out to the server located in another part of the plan, and it's unable to dump all its stored data. So it's letting you know it can't take in any more information into that PLC until something has been pushed out. On your operator PC, your main operator PC, it could have some kind of message that said error occurred when connecting to SQL server. So once again, it's letting you know one PC is not able to connect to another PC. On a rapid loader PCs, you may see a message something like unable to establish SQL connection. And then on our digital entry keypads, the MBTs that are at the rapid loader, you may get an error message that says no connection to SMX system or SMX error 2603. These are all indications of loss of communication. So for fault isolation, this first thing you're going to do, check network switches, check servers, make sure everything's powered up and that you have no error indications. Try pinging the affected IPs and other IPs. Check cable connections. Test with a RJ45 tester. Conduct a full power down and reboot. Re-terminate, replace cables, and then if you've done all that and you're still having an issue, then of course contact customer support. So checking the switches. This is actually an online picture where we're able to dial into the switches and see some connectivity. But you doing this locally, you would be able to get a bunch of the same representations. So when you're looking at the switch, you're going to have LED lights on here, and you're going to see whether stuff is connected and blinking and whether it's transferring informations into the different ports. So you'd be able to, just for example, if you traced out the display for Rapid Loader 1 and you saw it's going into pin 6 or connection 6 of the switch, you could go ahead and see if it had communication. The example I have over here, I can bring up different port statistics and see whether or not I'm getting packets actually transferred, packets received, check the overall speed. For you, you'd be looking at the blinking lights and be able to see if you actually got to transmit and receive up and down. Going to the server itself, if you go and log into the server, you may be able to bring up this service manager page, which is going to be this icon down here. And then we can go ahead and bring up the different services and see if we have some kind of issue going on, that some kind of communication has been turned off or didn't boot up correctly. From the server or maybe the operator PC, we could bring up some kind of advanced IP scanner or angry IP scanner and go ahead and do a small search of the different IP ranges. So this is getting back to knowing the IP ranges that you're searching for. If I was searching for W2, I would be putting in a 10.8.2 IP scheme. If I was looking for, let's just say, my folding machines and maybe my tunnel, then I could do a search range of something very low, maybe between 10.8.2.2 and then going up to 10.8.2.34. And this would include all of those major machines. See if I'm actually able to ping it. And if I have good connection. Additionally, from your operator PC, if we would just bring up a command prompt. So command prompt is going to be this DOS prompt that's down here. If I would click on that, I get this black page that opens up, and you don't really care about what user comes up. All you want to do is type in ping, P-I-N-G, with a space, and then you enter in the IP address that you're concerned about. So I go 10.8.2.2. Hit enter, and then what it's going to do is it's going to go ahead and ping out that data. And here we can see the amount of bytes that was transmitted, and it's going to go ahead and give me the ping times that it took. So all this is good. 4 packets sent, 4 packets received, 0 loss. So this is letting me know that I have a good connection. So that's letting me know my ping is working. And now if I was concerned about 10.8.2.3, I could do the same thing, and maybe I get nothing returned, unable to connect, unsuccessful, something like that would come up. And then finally, I want to go ahead and show you an RJ45 tester. This is a device that's used to check the RJ45 cables. They're very inexpensive. So once you turn it on, what it's going to do is send out a signal down each one of those lines, and if the transmitting wire and the receive wire are good, you'll see the individual components light up. If one of these wires weren't good, then you would see no light up right there. So wire 1 good, wire 2, 3, 4, and so on. So for here, it's transmitting on 4, and if there was a break in the wire or a bad connection, if you didn't get a light showing up here on 4, then you know that wire's bad. This can also show you cross wires. So if I'm transmitting on 4 and 3 lights up, that lets me know that I'm plugged into 4 over here, but the wire got wired in at pin 3 over here. So that'll enable you to test that. So that's all I have for this introduction. Thank you for your time. And if you have any questions, always please contact customer support. Thank you.